In video A, we talked about what a derivative actually is, and that is the slope of the tangent lines, and we came up with a way to represent the slope of our tangent lines as a limit formula. The idea that a secant line, the points can slide down and become a tangent line. And we came up with this formula. So now we're going to look at finding the derivative of a function. And we need to talk about our actual notation. So in Algebra 1, we used the letter lowercase m to represent our slope. In calculus, we have a couple different notations. You're going to see it written as f prime of x. You might see it as dy over dx to represent the change in y compared to the change in x. Remember, y2 minus y1 over x2 minus x1. That's like saying this. Okay, that d representing the delta. You may also see it written as y prime. I personally, if the function's defined as y equals, taking the derivative, you can write it as y prime. I personally prefer these two notations because y prime can get very easily mistaken for a y to the first power. So let's look at an example really quick. We might look at a couple using this limit notation and going through the algebra steps to find the derivative of a function. Let's look at the function y equals, or f of x equals, 3x squared minus 2. Okay, so what's going to happen is we are going to use the point f(x) and f of x, and x plus delta x, and f of x plus delta x. So that literally means we're going to plug x plus delta x into x in this function. So f prime is how we're going to write the notation for our derivative, is going to be the limit as delta x goes to 0 of y2 minus y1 over x2 minus x1. Okay, so f of x plus delta x is going to give me the following. 3 times x plus delta x quantity squared minus 2 minus just the function. And all of that's going to be over our delta x. So at this point, if I were to plug in 0, so if I picture taking this number and plugging it in for x, or the delta x, excuse me, because it says delta x goes to 0, if I plug it in for delta x, I'm going to get 0 out, because this piece will become 3x squared minus 2, and then I'd be subtracting the 3x squared minus 2, and then putting in 0 here gives me 0 over 0. So that means algebraically something must cancel out. Okay, so I'm just going to keep writing my limit as delta x goes to 0. So I'm going to multiply out this x plus delta x. So I'm going to have 3. So that's going to give me x squared plus 2x delta x plus delta x squared minus 2. And I'm going to carry the negative through on this piece. That's going to give me negative 3x squared plus 2 over delta x. So we'll do one more line here. So I'm going to carry the 3 through to the top. So that's going to give me 3x squared plus 6x delta x plus 3 delta x squared. And then my 2's cancel out, because negative 2 plus 2 cancels out. And then I would have minus 3x squared all over delta x. So I'm just going to recopy this down onto the next page. Alright, so just copying down what I have again so far is f prime, my derivative, is equal to the limit as delta x goes to 0 of 3x squared plus 6x delta x plus 3 delta x squared minus 3x squared over delta x. So again, I see more stuff that cancels. The 3x squareds are going to cancel. So that's going to leave me with the limit as delta x goes to 0 of, and everything I have left has a delta x in it. So I'm going to factor out a delta x from my stuff that's left over, and that's going to leave me with a 6x plus 3, and since that was a delta x squared, I'm still going to have 1 left over delta x. So now algebraically, I see that my delta x's are going to cancel out, and that leaves me with 6x plus 3 delta x. At this point, I can plug in 0 for delta x. So if I plug in 0 for delta x, I'm going to get 6x plus 3 times 0, which is 6x. So my derivative, f prime, is 6x. That represents the slope of all tangent lines at any given x value for the equation y equals 3x squared minus 2. In future videos, we'll look at other types of functions. We can look at exponential functions, we can look at trig functions, and there's a bunch of different rules that you will learn about how do I find the derivative. There's power rule, chain rule, and so on. But those will be in future lessons.